Okay, we're just going to dive in right now. Hello, everyone. My name is Christine Hammond. I'm the Executive Director of the AIA Long Beach South Bay. Welcome to our weekday online webinar. The topic is as-built best practices with precision property measurements. Before we dive into the program, just a couple of announcements. This is our last learning unit program for 2023. We start off in January with our usual Barchitecture. That's an in-person social event, first Thursday of almost every month. And of course, January is always held at JoJo's here in Long Beach. So look for that on our calendar. And then later in January on the 24th, we have an in-person social media program. And that's going to be really interesting. It's geared for sole practitioners, small firms, not just architects and designers, but also allied members, vendor reps, to learn how to use your cell phone in promoting your business and growing your business. So without further ado, I'm going to hand it over to Cameron Slatterbeck, who is with Precision Property Measurements. And they have been a long supporter of AIA Long Beach South Bay, and they're a platinum level sponsor. And go ahead and take it away, Cameron. And for those of you looking for learning units, we're going to put the attendance link in the chat. Okay,
Cool.
Cameron, go ahead.
Yeah, thanks, Christine. Can you just give me a shout if you can see my
Yep.
screen? All right. All good?
Good.
Cool.
Yep.
Appreciate it. Yeah. So thank you guys. Appreciate you and the Long Beach South Bay chapter for having us back to discuss more about as-built surveying best practices. If you did attend our part one last year and even the year before for this course, that kind of touched mostly on getting as-built using traditional methods. So welcome back for what we're now calling our part two. Kind of as technology has progressed, though, we definitely get a lot of questions here at PPM regarding laser scanning and what kind of equipment we use. And so that's exactly why we ended up creating this part two, and that's exactly what this covers. So as Christine mentioned, my name is Cameron Slatterbeck. I'm the Regional Director for our Southern California office here at PPM. I've been here for about 13 years now and kind of seeing firsthand how the impact of technology has revolutionized industry standards for creating as-built plans. So let's get started. AIA Long Beach South Bay, wanted to mention this real quick. They're the continuing education provider for this next program. And here's, Christine mentioned threw this in the chat, but go ahead and register here to be eligible for that raffle. We're giving away that Paris Skyline, as Christine mentioned in the bulletin. It's a Lego set, so I'll leave this up for a few moments, maybe 20, 30 seconds. Go ahead and use that QR code or the chat that Christine popped in the chat. And then we will get started soon. So hopefully everyone's able to do that. I will throw another slide toward the end, a reminder to go ahead and get those units. So let's move on. So course description here. So as-built surveying best practices part two. It's a comprehensive course that was developed in response to architects' direct needs to obtain as-built plans prior to beginning their design process. The class is intended to educate the attendee about both parts of the as-built survey process, both gathering the field measurements of the structure, as well as using that data that you just collected to draft or model the final plans needed by you, the architect. The first part of the course focuses on laser scanning, which is quickly becoming adopted as the main form of field measuring because of its efficiency and accuracy. The second part of the course explains the second step in creating as-built plans, which is to document those existing conditions using the point cloud that you just gathered into AutoCAD 2D drafting software and or various 3D BIM software. When attendees complete this course, they'll understand the full process for creating as-built plans using laser scanning, as the main method for gathering those field measurements. And so learning objectives here. So number one, recognizing when and how to use terrestrial laser scanners to gather those field measurements. Number two, know when and how to employ mobile scanners instead of those terrestrial scanners to take those field measurements. Number three, understand the role that point clouds play in displaying the data in a usable form. And then finally, number four, becoming familiar with those techniques for drafting and modeling as-built scope items in AutoCAD, Revit, and other BIM software. So we have this split up into three sections. Number one, laser scanning. Section two, we'll be talking about point clouds. And then section three, BIM, building information modeling. And throughout the presentation, we're going to have a series of polls in which I'll ask you all multiple choice question. And please, if we could hold all the questions to the end, maybe you could type them in the chat now and we'll take inventory of those later on. But save your questions for the end, and we'll have that whole Q&A section at that time. And then we'll open up those questions. So let's get started with section one, laser scanning. But first, before we get started with that section one, we've already got our first poll. So my question to you is, how do you generate your as-built plans? Is it A, you create them yourself? B, you have an internal team create them, or C, you partner with an as-built firm? So go ahead and type those answers in the chat, and we'll take inventory of those. Let's see some answers rolling in slowly. Don't be bashful. I see a couple of people partnering with as-built firms, which is exactly what we like to hear. Cool. Yeah, I see people kind of creating themselves. I'm sure we'll get some sort of, everyone does it a little bit differently, of course. Cool. Well, thank you for providing your answers. We'll have some more polls moving forward and type those answers in the chat if you can. So now starting with section one, let's first start off by touching on technological methods for both mobile and terrestrial LiDAR scanners. So updating or even replacing a proven method for doing something to utilize the newest technology certainly is not easy, no matter what industry you're in. The first step you take is the most important, though, and the rest is just hard work and diligence. Even though it may be difficult to transition, making that change to laser scanning as a survey method provides you with several things here. So fast data acquisition for sure. It's more accurate than any measurements that can be taken by hand, and it reduces the odds of human error dramatically in the field. This technology can be purchased, rented, or contracted, so there's options there. Provides a thorough solution. It allows surveyors to gather more data than needed to complete most projects. And then maybe even most importantly, provides a digital twin to pull additional data down the line if that project ever needs to be revisited for any reason or additions need to be made to the scope of the work, you'll probably have that data on file. So what does LiDAR mean? We hear about it in the news and articles about, autonomous vehicles, robots, things like that. And it's the same kind of technology that we use to get survey data. It stems from the word radar, which stands for radio detection and ranging. That's obviously a much older technology, but it works in the same way. So LiDAR is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. Each one of these illuminations can be, I guess, considered a measurement, and each single measurement taken is logged, and throughout the course of the scan, millions of measurements are taken in all directions. So let's talk about some LiDAR scanners currently used for architecture, engineering, and construction. So when we need very accurate measurements or a lot of very intricate detail captured for historical projects, structural or engineering analysis, or prefab projects, we go to one of our favorite terrestrial scanners, and that is the Leica RTC 360. So even though this needs to be set up on a tripod, the individual scan times for the RTC 360 are relatively short compared to other terrestrial scanners, making it the fastest terrestrial option that's out there. The iPad app also helps make sure that you can get or check your point clouds before leaving the site. The RTC 360 is extremely precise and gathers so much data that point cloud files can even be sometimes over 500 gigs. So huge, huge files. Um, Whether we use the onboard camera to make a color point cloud or not, we always get very, very dense, very accurate data that allows us to draft and model ornamental detail, pipe valves, other intricate details with high precision. Because our final data is made up of hundreds or even thousands of scans sometimes with this scanner, it does make it an ideal scanner for the starting and stopping sometimes required in busy spaces such as like hotels, shopping malls, industrial spaces, places, things like that. In this next slide, we'll actually see a short video of a scan taken with the scanner. So while our other scanners can be moved while they're operating, the RTC 360 needs to be placed in multiple positions all over the building to get a full set of measurements for our plans. Each red dot that you see there in this video, that's a place where we strategically position the scanner to gather the black and white data that you see here. Even though we did not use the camera for this data, you can see how much detail we can get using just the black and white measurements gathered. Each black and white point or pixel, it's a representation of an actual laser measurement, accurate down to less than 2 millimeters. So this means that this entire 3D picture that you're looking at is dimensionally accurate. We use this data to help an architect actually identify floor sagging, wall sagging, and some other structural issues before a major remodel of this 100 plus year old casino that was in Colorado. Really cool project. And then just for reference of a final result of a project completed using this RTC 360, this is a Revit model. This is actually the Olympia Hotel at Capitol Lake in Washington. This was almost 200,000 square feet, 178,000 to be exact. And it took us about 176 hours to fully model the hotel in Revit. Looks pretty cool. So we've chatted a bit about terrestrial or stationary scanners. So now let's dive into a couple of our most commonly used mobile scanners, and those would be the GeoSlam Zeb Horizon and the Zeb Revo. So some general points regarding mobile scanning and processing. Using a mobile scanner is preferable if you need accuracy and your time on site is limited. Since most individual scans take only 15 to 45 minutes on average, we recommend that you process the scan on site to check those results before you leave, so you don't get yourself in a position where you find out later that you didn't get all the data you needed and then have to return to site. Once the scan is complete, you need to use the SLAM algorithm software, which interprets all the measurement and movement data from the scanner to produce the 3D point cloud. And then after that SLAM algorithm produces a 3D point cloud, you then proceed to review the point cloud to ensure accuracy. Most errors in scanning or processing can really be spotted pretty quickly. And actions such as rescanning can be taken to ensure the overall accuracy of your project when the time comes to draft or model. We'll actually touch on some of those potential point cloud errors a little later as well. So this is what point cloud data looks like in plan view. So you can see that even though there's no photo-based colorization of the points, these points are colored on sort of like a height ramp, where points are at different heights, and they're showing different colors on a spectrum where you can see on the left there, red is at a lower height, blue is higher. Coloring the points this way makes it easier to see important features in the point cloud, even without that photo colorization. So there's two types of GeoSlam mobile scanners that we love, like I mentioned, the Horizon and the Revo. The Horizon scanner, as shown in this picture, is one of our favorites. The scanner reduces the time spent on scanning by up to 90% compared to that terrestrial scanning that we were just talking about. It collects 300,000 points per second with a 6 millimeter accuracy, and it covers a range of 100 meters. So it shoots a really, really long distance. You can pretty much use this to scan just about anything that's visible, of course. We've used this to scan, single family residences, commercial spaces, generally under about 50,000 square feet is kind of the threshold. Restaurant spaces, retail spaces, warehouses, you name it. Like I said, you can scan up to about 50,000 square feet, and that's just in mere hours. And this, of course, does vary by, kind of construction type and density. And this scanner actually costs about $45,000, including software. And then here's an example of a project we scanned using the Horizon. So this was a 9,000 square foot single family residence located in Washington, D.C. And they requested our remodel package, which includes floor plans, roof plans, exterior elevations, as well as, of course, the still photos that we take on all of our projects. So this one took about 6.5 hours to scan and get those photos, and then estimated drafting time of about 36 hours to fully model that. And now this is the Revo scanner. And very similar to the Horizon, this also reduces the scanning time by up to 90% compared to those terrestrial, stationary scanners. This scanner collects 43,000 points per second, so considerably less than the Horizon, but still a ton of data with a similar 6 millimeter accuracy. And like the Horizon, you can scan up to about 50,000 square feet in mere hours, and this varies, by construction type as well. And this scanner is just a bit cheaper, considerably speaking, with a price about $30,000, including software. And finally, here's an example of a mixed use project we scanned with the Revo. This is a 27,000 square foot building located in Seattle. And this client requested floor plans, roof plans, exterior elevations, RCP, as you see there, and interior elevations. And you can see what that RCP ended up looking like. It was a pretty dense ceiling situation up there. This one took us about 8 hours to scan and take photos of, and then another 36 hours to fully draft the project. So next up, we have section 2, which we'll go over point clouds. So reviewing your data well before attempting to create a set of as-builts from a point cloud is a must. If there's any kind of errors with your cloud, it certainly does happen, then using that bad data can either stop you in your tracks later when you're going to draft or model, or even worse, result in a completely incorrect set of as-builts. So once your scan has processed, you'll need to review that output. Make sure, did you cover all the areas? Are there any flaws or errors? And ensure there's no drifting. And we'll see drifting, an example of that in a second here. So most scanners have a range of hundreds of feet, which can produce a lot of data outside your project that you don't need. You may need to clip or crop your point cloud to reduce the file size by getting rid of that unwanted data in areas that you don't need. If you have to produce multiple point clouds for a large or complex project, it'll be important to get comfortable with that point cloud software that'll allow you to merge or register your clouds more easily to manage that data. So to reiterate this, since the scanners have such a wide range, you want to trim or crop those point clouds to eliminate the excess data, especially from those long range scanners. For large projects, utilize the point cloud software to merge and streamline data management. Much like the traditional method of sketching and measuring, which we've kind of went in detail in part 1 of this series last year. Properly scanning a structure takes lots of practice to do correctly and efficiently. Once you're practiced with scanning and know what to look for, what kind of errors to look for and what may have occurred, you'll have the most reliable version of data that you can gather in the field. You can be confident that the as-builts that you created will be fully accurate and ensure a smooth and safe renovation as it progresses. So when you're scanning specifically attics, foundations, large sites, or even multi-level structures, you may run into issues getting all that data to fit together. Areas that are hard to access, have lots of reflective surfaces, maybe places that have fewer unique features like office hallways or open empty spaces, those can all pose a challenge. So processing requires all areas have data connecting one area to the other so they can properly be like glued together. Mirrors, moving objects such as a lot of people or even cars, etc. Those can trick the process and therefore give you a bad output. The screenshot you see here, that's of a multi-level structure and is a space with fewer unique features, and additionally is an open empty space, kind of checking off all the potential problem points there. So this did actually pose a challenge while we were on site. So make sure to look for any drifting which I mentioned a couple slides ago, which that can occur when the software has trouble putting all the points together. If this does occur, then you can try some reprocessing options or simply scan the structure all over again. Uh, Drifting includes reflection noise, other data noise, needing to use other devices potentially for control on larger buildings, internal scanning errors, mirrors reflecting data and duplicate data. It's important to keep an eye out for multiple types of drifting inside and outside of the building, as you can see there in that example, in that photo. That's a pretty clean example of what drifting kind of looks like. So now that you've collected the data using the methods that we discussed earlier, it's time to create the actual plan sets. However, before we move forward to section 3, building information modeling, I'd like to pause here for the next poll. So I'm curious, which software do you work in? And there's a handful of options there. So AutoCAD, but you actually plan to work in AutoCAD for the rest of eternity. B, AutoCAD, but you're interested in working with other software, soon down the line. C, you're working in Revit. D, you're working in ArchiCAD, or E, SketchUp. So I see some answers already coming in the chat. And I imagine we'll see a kind of a spread right there. Obviously, AutoCAD is still kind of king, but we've seen this kind of movement going into more of the 3D realm over the last few years, at least. And I think we're seeing that a little bit already in the chat. So good examples of that. So keep those answers coming in the chat, and we'll keep an eye on those, and we'll move on. So now let's dive into drafting from the point cloud. So when you're drafting from a point cloud, the first thing you'll need to do is get into a drawing environment. Point clouds can be imported directly into AutoCAD or Revit, as well as other architectural software. If you do use Autodesk products, but judging by the chat, many of you guys do, you'll need to use an application called Recap to prepare the point cloud to ensure that it works within their entire software suite. Drafting from a point cloud in AutoCAD is mostly straightforward, but it does take some getting used to. And then point clouds are ideal as-built data sets for creating Revit models, but the Revit point cloud tools can still feel a bit lacking. So first, let's talk about CAD drafting from a point cloud, specifically in plan view. So in the image here is an example of a slice, or like a horizontal section cut, if you will, of a point cloud in plan view. Regardless of how you get your survey measurements, it's good to start any as-built by starting with the floor plan, of course. When drafting in CAD from a point cloud, you'll want to ensure that your cloud is positioned orthogonally so that you can use that ortho function in CAD to easily draw your lines. If you're going to work on elevations or need to extract any heights from the point cloud, it's also good to position the point cloud in the Z-axis. So typically we start by lining up the finished floor surface of that first floor at a 0, 0 data point. And then once you have the point cloud well positioned to begin drafting, you should be able to derive all the walls, doors, and door swings, and any other visible architectural and structural information right there from the point cloud. Some items like windows, those can pose some difficulties when you're trying to extract width and height information. But with the diligence and practice at manipulating the point cloud, it does get easier. Some scanners will not pick up smaller items. This is a big one, especially if they're flush with the walls or ceilings, like can lighting, electrical switches, outlets. Trying to locate those in the cloud can be very time consuming, and in that case, it might be better to just resort to using your more traditional measurement tools while you're in the field and just sketch and measure those items. Now let's get into drafting other views, such as an elevation from the point cloud. So when you're working in a 2D drafting environment, it's not only important to have your point cloud well oriented in that drafting space, but you'll need to be well practiced in manipulating the coordinate systems in the point cloud sections. Once you do, you'll see that this is where there's a huge advantage in having a complete point cloud for drafting. Provided that you were able to access the roof and scanning, which can always be a challenge. It's not always possible, but if you did, you'll see that every height that you'll need to properly draft a roof, exterior elevations, and any section cuts you might need will be right there. As with electrical and RCP components, sometimes it is beneficial to revert to those traditional methods to sketch elevation, ornamentation items that you'd like to include in that drafting. So now that you've seen how we set up the point cloud and AutoCAD for drafting, let's also examine how this setup works in Revit. So the LOD system, or the level of development system, was created for the AEC community to put standards on BIM drawings. It describes the different ways in which 3D objects can represent existing or design elements in a BIM model, with level 100, of course, being the lowest, meaning you just kind of mass your objects roughly, and then going all the way up to level 500, which is the highest, and that being so detailed and exact that you're essentially building a virtual version of the structure itself. When you're modeling an as-built plan, LOD 200 we find is the most applicable range, since you're assessing a structure that's been built from the outside, with many interstitial spaces being inaccessible. The specific construction of many architectural and structural elements cannot be determined. So that's typically what bumps you up to that LOD 300, and therefore that's why LOD 200 is kind of that sweet spot. So first, let's talk about modeling the plan view items from a cloud in Revit. So when you're modeling in Revit from a point cloud, you'll want to ensure that your cloud is positioned orthogonally in plan view, so that you can use that ortho function to place walls. Then set the finished floor to your 0, 0 level, much like with CAD, and then create and set all those other levels, key features in the point cloud. Once you're done setting those finished floors, you can start adjusting your view range and view depths in your plan views to add wall, door, and window families in the places indicated by the point cloud. And so similar to drafting in AutoCAD, the first thing you need to do to work with the point cloud in Revit is make sure that it's in a recap project format for use with Autodesk projects or products. Using the point cloud to guide modeling in 3D can be more complex than drafting in 2D. However, the benefits of having all elements of a building related to each other in a set of 3D drawings can be valuable to your design and planning process, because you can see the way that things interact with each other in a way that you just can't do with a set of 2D drawings. Viewing the point cloud and model in 3D provides even more information about how structure, MEP systems, and architecture interact, more than you would find with a model alone. Modeling an as-built in Revit may seem overwhelming at first, but a solid order of operations, as with anything, for creating a usable Revit model, will go a long way. So now going from plan view into modeling vertical information. So as with AutoCAD, this is where there's a huge advantage in having a complete point cloud for modeling. Drawing those sections and adjusting section depth is crucial to viewing point clouds effectively when adjusting window heights, door heights, creating roofs, things like that. Then, of course, practice patience. Roofs are tough. They always are. And they're definitely tough to model, but even more so when you want them to really accurately match that point cloud data. So there's some advantages to having a BIM as-built, which some may not even know. So sometimes a three-dimensional model is only considered maybe for a presentation for design purposes, but it can also be useful as an as-built as well. So the as-built, BIM model can be viewed in multiple phases. So you can easily switch between existing, demo, proposed, and alternative proposed phases. When you have a BIM model, moving from the design phase to the construction documents phase of a project is far more efficient. Having an as-built BIM model can make it easier to understand a project that you haven't visited yourself, since you can cut sections, you can view interior spaces, and review that massing all in 3D. And then some say, Revit offers a more intuitive design experience, and it allows users to present 3D images at the planning stages to, the owner, planning departments, parties like that. So now it is time for our last poll before the Q&A session. So what is the most important factor to you when obtaining your as-built plans? Is it A, quality and accuracy, B, timeliness or turnaround time, C, efficiency, or D, cost? And I would say let's try to avoid using the blank answer E, all of the above here. Let's see which one you prefer most there. And go ahead and type those answers in the chat if you can. A and B. Aaron says A and B. I would imagine quality and accuracy is usually most important, but I could see arguments for some of those others depending on the project, of course. But cool, see some answers in the chat. They all contain A, as my suspicions led me to believe. So thanks for piping in there. Now, I said I'd bring this up again. If you didn't already, Christine put that in the chat at the beginning. Go ahead and use that QR code. Make sure you sign in to get your learning unit and be eligible for that raffle. And now let's open it for questions. Any questions that you guys have for me? Were there any questions that came into the chat by chance, Amber? I don't think I saw any.
So yeah, there weren't any.
Okay. Well, if you guys have questions, now's the time. If not, that's certainly fine. We can touch base offline. Amber, maybe we could put our information there in the chat as well. And we might even do like a rollout of some of the most common questions and answers when this is released afterward. Andrea, which software works best with this as far as point clouds go? We deliver projects in all of those options that we laid out. So AutoCAD still being kind of the most common. Certainly the 3D realm, it's going in that direction. And we did touch on some of the trickinesses of that, but it still, yields a great product. So I would say you can't really go wrong with AutoCAD, Revit, ArchiCAD, SketchUp. Brian, not a question, fact. PPM's the best. Appreciate that. Always our biggest hype man. Thank you very much. Yeah, any other questions? Again, feel free to reach out.
Did you see that one follow-up from Andrea? Would you advise moving away from ArchiCAD?
Would I advise that? Gee, what do you think?
Are
you thinking of her, Andrea?
I saw you, Andrea. You were our one at least publicized ArchiCAD user. Nobody else put that. And maybe they're just hiding and underground. I don't know. But
I was going to mention Brian would say no, because Brian's like our biggest ArchiCAD user that I know. And I'm sure he has reasons to say no to that. People are definitely using it.
Yes, we actually are surprised because we've provided AutoCAD for forever, and then of course moved into Revit as our client needs change. And just in the past 2 years, would you say, Cam, we've been diving into the ArchiCAD realm because there's quite a few users, and it seems to be this underground, like a community of ArchiCAD users who you don't really see a whole lot because of this Autodesk conglomerate. But people love it. People love it. They don't have to bow down to Autodesk, and it works with point clouds. We can load point clouds right into ArchiCAD. And I haven't heard any issues with it, besides potential issues that would apply to any 3D software.
Right. And I've noticed, and Tony, you could add to this too, but people use it both as a primary software and also as secondary software. Right. I know a lot of you guys use multiple, so that's certainly a thing.
So if you love it, Andrea, you don't have to change.
Stick with what works for you and what you love.
Right.
Yeah, no, thank you for the question. Yeah, anything else?
Cameron,
we went on time, Christine. I think we blazed through that.
Yeah, plenty of time left. So if anybody wants to go ahead and unmute themselves to ask some questions, we are good with that.
Who's gonna go out and buy a scanner? No, no one.
So,
Price tag scare you?
There was a couple people who
Take your
joined
shot.
pretty late, and PPM is going to post the video to their YouTube page
Yeah.
later in the week or by next week. So you can catch the first half of this.
I have a question.
Cool.
Go ahead, Richard.
How do you ensure accuracy when you're actually drawing from your point model?
Oops, sorry, I couldn't quite hear that. How do we ensure accuracy when we're
I mean, how do you know you're really accurate when you're like tracing your point model when you're drafting it for people?
Yeah, I mean the kind of going back to being able to identify how, I mentioned drifting with the point cloud. Those errors in the point cloud typically yield themselves pretty quickly, early on. So you'll know quickly, right, when you're getting into your drafting or modeling process that there's something not quite right. And almost always it'll be visual. It'll kind of slap you right upside the head with it. And then, if you're not seeing that stuff, you can generally trust that point cloud data is far more accurate than any data that you could probably take by hand in the field. Did that answer your
Yeah,
question at all?
definitely. Thank you.
Cool. Yeah, thank you for the question. Anything else?
Actually, this is your company is what now?
Precision property measurements.
Yeah, I've used you twice. I'm really happy.
Yes.
You produce for us.
Awesome.
Yeah, no, thank you. I appreciate it. I saw you on the registrant list and definitely remembered.
I will always use
So
you in
thanks
the
for
future.
attending.
I'm never going to hand measure anything again.
That's the whether you use PPM or not, I think the technologies go in this direction. You want to be able to trust the plans that you're working from to get your project started off right. And so that was the key, in producing this class. So I hope that everyone's kind of seeing the positives and the benefits to using scanners moving forward. Whether you're doing that yourself, you're renting it out, however.
Cameron, do you want to mention about the raffle, how you guys are going to handle the raffle?
Yeah, that's the last one. Just wanted to, if there's no, other questions, of course, thanks to all you guys for attending. We hope we were able to, provide some insight there. Perhaps maybe get to collaborate with some of you guys in the future. And then we'll be reaching out to get in touch with our raffle winner. We're going to do that offline. It's that Paris Lego set. That Skyline Lego set looks pretty cool. So we'll be in touch. What do you say, Amber? In the next week or so? Less than that?
Yep, a week or less.
Yeah. So yeah, good luck to everyone.
Great. Thanks so much.
Yeah, thank you guys. Appreciate it. Christine, anything else?
Yeah, I'm going to put my email in the chat if anybody needs a certificate of completion, to email me directly, and I can send that to them as well. Some people who are not architects need it for other certifications. So my email address is in the chat. Reach out to me. The units will be reported within the next week to AIA for those of you who need learning units and filled out the attendance form.
Cool. I'm going to punch my info in the chat as well, just in case anyone had questions offline.
Yeah.
And I will stop sharing.
Any other questions from the group? You want to talk about any of your other offices? I know you guys are not just Long Beach, so feel free to use the last few minutes to
yeah, sure.
tell everybody a little bit more about PPM.
Yeah, PPM. So we started, what's it been now, Tony? 21 years, 22 we're going on? You've been here for almost all of it. I've been here for only 13 of them.
Yeah, 22.
So we've got offices. Our hub is in Long Beach, so very local to many of you. And then we opened our Bay Area office several years ago, followed by Seattle, DC, and Miami as well. And then we've got a special operations team that kind of covers all the in between. So we've got good coverage there.